Welcome everyone and welcome to our session on Matplotib. So in the previous sessions on Matplotib, we just learned about how to draw a plot, that is nothing but how to draw a plot between different points on the axis or the coordinates that we have. And then we also saw about scatter plots, what are the differences between your line plots and scattered plots. So if you wanted to draw two different plots on the same line, so what is the difference that we have? So all those simple things that we learned in the last session. So in this session, what we'll be going to do is we'll be learning some kind of bar plots. Then we'll be learning histograms, as well as we'll be learning some other parts, that is nothing but our pie charts and multiple graphs inside the same window. So those information we'll be trying to learn. So we'll start our first the tutorial with our bar graph. So what is bar graph and how do we represent our bar graph is very important to understand. Okay, to start with, it is very simple. Bar graph is nothing but a kind of graph where we'll try to compare two different data. So if we have two different data for comparison with similar kind of situations or similar kind of categories, so we try to use our bar graphs for basically comparing two data. So you need to understand the basic difference between your regular plots and scatter plots as well as bar graph. So bar graph is indicating there is comparison between two quantities or two categories. So if there is no comparison or the variation between two quantities, you are not using your bar graph. So you will be using your plots or scatter plots. So to draw a bar graph, it is very simple. In case of your Python, it is really easy. In case of using your Matplotib, yeah, it is similar to our regular bar graph. So it is simple. So we'll use import from Matplotib. So what we'll do is we will import our pie plot. So what is pie plot is nothing but from our Matplotib, which contains majority of the libraries and various styling elements. So what we are trying to do is we are trying to implement a small part, that is we are trying to import a small part that is called as pie plot. So we'll call it as PLT. So what is this PLT? That is nothing but an alias name that we are trying to give our pie plot. So this pie plot or your regular graph as well as your scatter plots all come in the category of your regular pie plot. So pie plot is nothing but Python plot. So Matplotib is a huge library. There are hundreds of functions, but we'll try to import pie plot, which contains our basic quantities for our graphs. So for our graphs, we need all the information. So for that, we'll use it. Okay. So what we'll do is whenever we are plotting bar graphs, it is not about one time that we plot, or it is not about one quantity that we plot. So we'll plot some two different or three different quantities. So the first thing that we'll do is we'll use the command called as plot.bar to plot. So what we'll be plotting now is we'll see how many cars have been sold in the last 5 years. So we have two brands, that is BMW and Audi. So we'll try to see how many cars have been sold in the past 5 years. So to see that, one first important thing that we do is we'll see the number of years. That is one quantity. So we are storing it in the form of list. So 1, 2, 3, 4, 5 is one quantity. That is the number of years. So 1, 2, 3, 4, 5 are indicating the number of years respectively. Then the amount of cars being sold. So let us take it as 50, 40, then 70, then 80. Okay, then 20. So these are nothing but the number of cars being sold. Okay, done. So what is the important things next that we should do is add a label. So what is a label? It is indicating that what defines what. For example, this label is indicating that my data is belonging to the car brand, that is BMW. So this is what I will enter. So I will enter BMW now. So that is my car brand. So then I can initialize the width. So why we need to initialize width is pretty simple to understand. So width is telling you what is the width of your bar. So when you are plotting a bar graph, so width is indicating that your default width is nothing but 0.5. So that is what you have assigned. So then what we'll try to do is we'll again plot another bar graph. But what we'll do is we'll plot it for the same years. 1, 2, 3, 4 and 5. That is nothing but we have 1, 2, 3, 4 and 5. Okay. So then what we'll try to do is we'll try to plot the number of cars. For example, 80, 20, okay, 50, 20 and 60. Okay, done. So this is nothing but 1, 2, 3, 4, 5 are the years. 50, 40, 70, 80, 20 are nothing but the cars sold by BMW respectively. So we have the same years, that is 1, 2, 3, 4, 5, and we have 80, 20, 50, 20 and 60 that are cars sold by Audi respectively. So I can name it as Audi. Yeah, so this is there, but I have another option to change my color also. You can use this color option, so to change the color. So if you want the color to be green, okay, if you want the color to be green, I can use it as G. So then what I will do is I'll try to add the width factor also. See, by default, if you don't mention any color, it will take a default color on its own. Okay, if you mention explicitly any color, so then it will take the same color. So I will use this 0.5 as my width. So now what we understood is pretty simple. So we are drawing two bar plots using two sets of data basically. Why we need two sets of data? Similar to normal graphs, you need x and y coordinates. In the x, what we are plotting, the number of years. So 1, 2, 3, 4, 5 are the previous years number. So then we are trying to plot how many cars have been sold by BMW and how many cars have been sold by Audi respectively. So here we plotted two graphs, which is pretty simple. So x-axis number of years, y-axis nothing but the number of cars sold. Here we are comparing two quantities. What are the quantities that we are comparing? The brand BMW versus the brand Audi, the number of cars being sold. That is why we need a bar graph. So very important to understand the utilization of bar graph and the time that you need a bar graph. So you don't need a bar graph every time. So then we will add something called as plot.legend. So what is legend? So as I told you in the previous session, so when we have maps when we have seen maps, so there will be a column called as legend, which will be telling what is what. Because you don't know because when a programmer does something, he knows which is the label for Audi, which is the label for BMW. But by default, if some business person or if a viewer or a customer is seeing those values, he will not be able to make the difference which is which brand. So very important to understand which person or which is representing what brand. So these two things are very important while drawing a graph. So the graph is not for you, it is for the person whom you are showing. So you need to give out some information. So this legend will tell which color belongs to which brand. So which color is targeting which label. So this is very important. So we have done this in the previous sessions, but here also we'll include the legend. Okay, so we need to add our X label. So in X label, what we'll add is pretty simple, number of years. So number of years is my X label, which is telling me how many years, previous years that I'm using or considering in this graph. So Y label will be what? It is nothing but number of cars sold. Yes, so Y label is indicating number of cars sold, X label is indicating the number of years. So this Y and X label, what are these? Nothing but labels. So labels are nothing but how you name a particular like a variable or how you name a particular graph. So what is the name for your X axis? What is the name for your Y axis? It is nothing but your X label and Y label. But you need to also give the title of the graph. So what is the title of the graph? It is nothing but telling you car sales data. So that will be a better name for my whole graph. So car sales data is a better name. So then I can use this plot.show. So what is this plot.show doing? It is basically showing out my graph. So once you plot the graph, it is not enough. You need to use this show option so that a window appears and the whole graph is plotted. So this is a small thing that we have done using bar plot. So basically taken in two quantities. One is number of cars sold by BMW and number of cars sold by Audi in the years respectively. That is nothing but in the past 5 years. So after taking them, what we did was pretty simple. We added a legend. So legend is telling me about which is what. So which color is representing what label. So which color is Audi, which color is BMW. So then we are plotting our X label, Y label and title. So if you have doubts with width is nothing but what is the width of your bar. So if you want to increase or decrease your width, you can do it. It is not a compulsion that both the widths should be same. So X label and Y label, you understood, those are names given to your X axis and Y axis. Title is nothing but the title for your graph. Plot.show is nothing but it will show you what is the graph that you have drawn. Okay, I will name my Python file as my graph. So done. So if you want to try to execute it, yes, so I can see and execute it. Green is nothing but my Audi, but blue is nothing but my BMW. But one thing I can notice here is pretty simple or pretty easy. So some of my blue values are not visible. So why is this blue values not visible, and how can I make my blue values visible is pretty simple. So whenever I am writing a graph or whenever I am choosing my graph, so this that is nothing but my first year, I can see that my Audi sales is around 80 cars, but my BMW sales I am not able to see. But in this graph I can see that my Audi sales is 20 but my BMW sales is 40. But in my third graph is also I am able to see that my nothing but my Audi sales is 50, my BMW sales is 70. So what is happening is, so you can't see the data in my first and fifth row. This is because of nothing but our width. So whenever we increase or decrease the width, so if we keep the width as the same factor, that is nothing but 0.5, what is happening is it is able to cover up the whole space. So you are not able to see the other data. You are not able to see BMW's data in the fifth year as well as in the first year. So what would I do to make the changes here? So pretty simple. So don't keep the width same as everything. So what you'll do is keep one thing as 0.6, keep the other thing as 0.2. So when you are changing the width, what happens is you can see the data that is nothing but if you are having different width, so you can see or make out the data that is actually the difference between the two or the categorical data between the two. If your width is same, the main problem that you'll see is you can't make out some data in some kind of rows and columns. But see here, when I decrease my width, I can see that my Audi has made a sale of 80 cars and BMW has made a sale of 50 cars. So similarly, your Audi, you can see the sales between Audi and BMW just by decreasing or increasing the width of my whole graph. So one thing is, one bar's width should be some data that is 0.6 and the other one would be 0.2 or 0.3 to make the differentiation between the two kinds of data available. So this is also very important. Never keep the graph that is width the same, because it will eat off some data and some data will not be visible at all. So this is very important to understand. And one more thing is you can add colors to anything. So this also you can add colors. So if you want to change it to red, okay, you can change it to red. Here if you want to put a color to, okay, if you want to put the color as blue, so you can use blue. So these are all the basic colors: blue, red, white, yellow, pink, cyan. So all those things are basic colors. You can go and check in the Matplotib website. So what is the exact color that are available in this entire range of Matplotib functions. So whenever I change my color, so I can change my colors in both the cases. So you can see how I can have an effective representation of my entire data. So this is one part. But the next part I want to explain is, so I have the data of the past 5 years of BMW, but I want to compare it with the next, or what we can do is the other 5 years. So if I have collective data of 10 years data, so I want to see how my first 5 years of sales is matching of BMW is matching up with my in the second 5 years of sales with my Audi. So I have 10 years of data. I will compare my first 5 years of sales of cars between BMW and the next 5 years of sales of cars between my Audi. So here what we are trying to do is we are not using the same nothing but our x-axis. So we are differing by x-axis. Now if you keep the width same also, it is not a problem, because there is no overlapping. There is no question of overlapping involved. So very easy to understand. So whenever you have data that is of different categories, so if the x-axis is different, so if you are not keeping the x-axis the same, so if you are using different x-axis, you can keep the width the same, because there will be no data that will be overlapping or merging between the two categories. So when you are comparing two different quantities in two different time domains or any other domain that you are trying to do, so this is how you can do. So I'm comparing my first 5 years of sales data of BMW with the second 5 years of data of Audi car. So this is for a span of 10 years. So total span is 10 years. So first 5 data of BMW with second 5 years of data of Audi. So we'll see what is the output that we'll get. So you can see it very clearly. So this is BMW and that is Audi. So you have your first 5 years data that is being there, and you have nothing but your second 5 years data of Audi. So you have seen the category using this legend. So this is the legend that I was talking about. So this legend is going to give you information of which belongs to what category. So red belongs to Audi and blue belongs to BMW. So this is how your data is getting represented in the graphical format. So it is not that like there need not be included in the same part. But if you want to display your data into two different time domains, so that is also possible. So what I can do now is I can see how my BMW performed in odd years. So I have data of nothing but one odd data. So I have odd years data, so 1, 3, 5, 7 and 9. So if I want to compare it with even number years data, that is 2, 4, 6, 8 and 10 of Audi. So this is how I can compare. So I have the odd numbers data 1, 3, 5, 7, 9 in my total 10 years data. I compare it with my even number years data. So I'll see how the sale is actually going to matter. So now we can see that how actually we are getting a colorful combination. So this is indicating odd year. So BMW we had 50 sales in even year. So but in the second year of Audi we had 80 sales. So this is how you compare between different graphs. So there is no standard method of telling which is the right thing to you. But one thing to understand is there will be always a factor of nothing but your own data representations and comparisons. So one thing you will do is you'll change the width and you'll change the color scheme in order to make your graph look more and more beautiful and more sensible. So this is one part. But there are some situations where you will need to have some horizontal graph. So what is a horizontal graph? It is nothing but whatever graph example that you saw right now. So this is an example of vertical graphs where all the bars are stacked in a vertical line. So this is an example of vertical graph. But I don't need my vertical graph, but I need my horizontal graph. So if you need a horizontal graph, it is simple. So instead of plotting plt.bar, you need to plot plt.bar h. So this h is indicating the graph is in a horizontal direction. So what you can do is, we'll see one, if we keep it in a what we can do is, there is no width inside your particular horizontal direction. So why there is no width inside your particular horizontal direction? Because in case of your horizontal direction, there is another parameter called height included, because width is there only in a vertical kind of graph. But in case of a horizontal graphs, you just have a factor called as height. You don't have a factor called as width. So one kind of graph I have given it as horizontal and the other one I have given it as vertical. So this is the beauty of my entire graph. So what I have done is, one kind of graph that is nothing but my data, that is my data of BMW car sales, I have given it in a vertical axis, but horizontal axis. But in case of my car sales of my Audi, so I have given it in a vertical axis. So this is also possible. One particular bar plot can be horizontal, so the other particular bar plot can be vertical. So this is the representation that you can see. So my Audi car data is in horizontal direction, vertical direction, but my BMW car data is in my horizontal direction. This is also a method of how to draw a horizontal as a vertical graph, both in a same graph. But I want to make both the values as horizontal, so I will add bar h to it. So this is how we can add horizontal kinds of graphs inside your bar plot. So this is here. So you can use this option. So this is how you can see, you can get a data that is nothing but your horizontal as well as vertical. So if you are trying to do how your horizontal and vertical which variations to your graph, you just need to change your bar to bar heads. That is how you are able to draw a horizontal as well as a vertical graph. So pretty simple, it is same, but there is another factor that you can change, that is called as height. So if you want to change height, so height is equal to 0.5. Okay, one is 0.5. So another one I can add it as height is equal to 0.8. So we'll see what is the difference that we have between the datas. So as you can see here, I have changed my data now. Instead of width, I am putting height. Why? Because in bar h, you have a different scheme that is available. So in bar horizontal, you can't put a width data because there is no width in a horizontal graph. It is nothing but our height. So you can see the difference between your height of 0.8 and the height of 0.6 or the data that we are given. So it is very simple to understand. So instead of giving the width option, so you can use the option called as height option. So both are the same, but in bar h you are plotting the graph in a horizontal axis instead of a vertical axis. So this is how you are drawing a bar plot. So what is the thing that we did is we compare two different quantities. So we can compare it with the same x-axis or a different x-axis, or the same y-axis coordinates or a different y-axis coordinates also. So if you don't want the graph to overlap each other, so you need to change the width in case of a vertical graph, but in case of horizontal graphs you need to change the height of the graph to have different, to see the whole data more clearly. So you can change the colors using color option. So label is indicating what is the simple thing or what is the label that you want to see in the entire graph. That is nothing but a name given to your bar plots. So then you have a legend. So legend is basically telling you what is the information or which color belongs to which label. So that information is also being given here. So and X label, Y label, names of X and Y labels. Title is nothing but the names of the title, and plot.show will show you the graph. So this is how we would draw a bar plot inside your Python Matplotib. But it is very simple. So whenever you have comparison, you will draw the nothing but your bar plots. But the next thing that we'll be going to try is pretty simple. The next thing that we'll be trying out is called a histogram. So what is histogram and why do we need histograms in our graphs is pretty important to understand. So first thing is, histogram is nothing but telling us how many times our data is getting repeated. So best way to understand histograms is an example of how many people in the class have weights of 55. So it is nothing but finding out the total number of outcomes of 55. So that is what is our histogram. So it is similar to finding out number of letters that are there in a particular, or the number of repetitions of the letters that are there in a particular sentence. So how many times the letter the has appeared in a sentence. So that is one kind of histogram. So histogram is nothing but counting. So how many times that particular value has appeared in our entire data is one thing called as histogram. So histogram is very useful in detecting number of words in a sentence. So how many times a particular word has been repeated in the sentence, or number of times a particular number has been appearing in the entire data set. So all this repetitive counting is very useful in the case of histogram. So histogram by definition is pretty simple. It is nothing but finding out the number of repetitions of any data that is present in our data. So you can find out the data representations of numbers, or in the case of text. So you can do any kinds of histogram. So it is nothing but counting the number of repetitions. So to draw a histogram in case of our Python Matplotib, it is very simple. So what we'll have is, we'll have a data called as population. So population is nothing but our data that is nothing but a list. So our population will have random ages. So what we'll do is, we'll have random ages of 20, 27, 28, then 22, then 20 again, then 27, then 50, 65, then 65, then 43, then 13, and 55, then 33, then 22, then 49. So this will be my population of ages. So this is nothing but a random data that I have. So okay, after doing that, I need to find out in what dimension or what is the kind of data that I have. For example, so I need to mention how many people are there between the ages of 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60, 60 to 70 respectively. So what is the simple thing is, I will need something called as range. Okay, so what I will do is, I will create a variable called as age underscore range. So age underscore range, or a better, I can use a variable called as age underscore range. So I need to mention the total range. So I have my first range starting from 0, then my second range will end at 10, then the third range will end at 30, so the fourth range will end at 40, then what I'll do is 50, so the next range will be up to 100. So this is how I categorize my data. So I am not having 60, 70, 80, all the data between 50 to 100 years will come between these ranges. So that is what we are trying to do. So what is this age range is telling us, how much are we dividing our entire histogram into. So we have the population, that is nothing but which is telling us what is the age of all the people that are there in a list. But we need to tell how we need to divide the data. So how we need to divide the data is, what is the break that I am giving. So 0 to 10 is one particular data gap. So I need to find out how many people are there between the age group of 0 to 10. Then 10 to 20 is also another data like a separation. So where it will find out how many people are there between the age of 10 to 20. So similarly 30, 40, 50, but there is only one like a space which has ages between 50 to 60. So all the ages which are there between 50 to 60, 50 to 100, so that will be having the gap between 50 to 100. So that is nothing but the gap. So all the other had a gap of 10, but this is having a gap of 50. So that can also be done. So it need not be only gaps of 10. You can have larger gaps and smaller gaps also. That is also one possibility. So this is nothing but telling me what is my range. So what is my data range? So how my data should be divided, range should be divided. It is nothing but 0 is starting, 10 till 10 is one range, from 10 to 20 another range, 30 to 40, 40 to 50, and 50 to 100 is one big another range that I have kept. So this is how I am able to range the data which I want to arrange. So this is how I want to calculate my histogram. So it is plotting a histogram is simple. So plot.hist. So what is the thing that I want to plot? Population versus my age range. So age underscore range is the data that I want to plot. So then what I want to do is I need to mention my hist type. So hist type is nothing but what is the type of histogram that I want to. So I will discuss the other types. So but the basic or default version that we'll be using is called a bar graph. So it will be in the term in the same shape or the same vicinity or the visualization of a bar graph. So that is how. But we need to also mention what is the width of our bar. So that is nothing but 0.8 that I'll mention. So it is pretty simple. We have a range that is nothing but the population. So in this range of data, so I am trying to find out how many times similar kind of data is occurring. So what is the similar kind of data? So in this particular total data that I have, so I need to find out what is the data that is between 0 to 10, 10 to 20, 20 to 30. It is nothing but finding out the number of repetitions between our data. So what is the repetition of ages between 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 100. So that is how I am trying to find out my histogram. So this is range is one list, population is another list. So I want to plot this against my population against my range. So then the histogram type is bar. Why bar? Because most of the histograms are like a bar graph type. So that is going to give you a better representation of how many repetitions are there in each kind of the division of data that we have made. And width is telling us what is the width of our range that is there, or the width of the bar graph. So very simple. So this is how we plot a histogram graph. So if you want to try to see the plot, it is plot.show. Very simple. So if you want to run it, so this is how it is giving me. So very important, we'll see both the data similarly. So we have this graph from 0 to 10. Do I have any age group data? I have no age group data. But from 10 to 20, so what is the age group of data that I have? It is 1. So because 13 is one age group that I have between 10 to 20. But from 20 to 30, what is the data that I have? So from 20 to 30, what is the data? I have data of 1, 2, 3, 4, 5, 6 and 7. So 7 is the right answer. So similarly, we have compared everything. But one thing we need to consider, the whole range, that is from 50 to 100, it is considering as one complete range. But what is the data that I have from 50 to from 50 to 60? It is nothing but I have two data, that is three data, 65, 65 and 55. So that is telling me what is the number of data between my 50 to 100, which is 3. So that is why it has plotted this 3. So this is how you draw a graph or a histogram in case of your Matplotib. So one thing I'm missing here is my X label. So plot.x label. So what will be my X label? It is nothing but age range or age group is better representation. So then I'll have plot.y label. So that is nothing but my population, or you can call it as numbers, number of people. So that is one better representation. So then I will draw a title to this graph. So what is the title to this graph? It is nothing but showing the population or the histogram. Okay. So this is a dot and this is nothing but title. So in title I need to mention histogram. So this is one of the simple methods that you can use to draw your histogram graph. So in histogram graphs you need to have two things. One is the data which you want to categorize or which you want to find out how many occurrences of what data is available, then you need to set a range. So range is very important, which is telling you how your data is divided. So what is the range that you are trying to see from this entire data? So very important to understand this. So if you want to try to graph it, it is similar thing, but you need to see the labels. So if you want to see the labels, you can print the graph again. So label is being seen here. So the label name is histogram, number of people and age group. This is how you draw a simple histogram. But we have some other types of histograms to see here. The next type of bar graph that we are going to see is pretty simple. So the only change that we need to make in this entire graph is instead of writing in bar, so we have something called a step fill. So what is the step fill going to do is, so wherever you have this kind of gaps in between the bars, so whenever you are drawing a bar graph, there will be gaps in case of your bar. So if I have chosen a width of 0.8, so you can see the gaps, but in case of your step fill, so there is no gap. So the graph is like the whole continuous part of this entire data that we have. So if you can see this, if we just choose a bar, so there will be gaps between our data because we have chosen the width as 0.8. The actual width size should be 1.0, which is like covering their entire data. But since we have chosen it as 0.8, there are some gaps that is there between the entire data that we have. But instead of that, if you use step fill, here, so what will happen is there will be no gap existing, so it will be like a one complete line that is drawn from the whole part. So you can't see the graph here, but you can see the variation. So the data variations you can see, that is 1, 7, then 2, 3, 4, and all the data variations you can see. But the only thing that you can't see is the gaps. So that is the whole difference between your histogram type, that is nothing but your data of the histogram, as well as your data that you have. That is nothing but the data that you have is the whole part of your entire population data. So this was the end of the histogram part, but we are left with one more thing. So what we are left with is another graph called as pie chart. So why we need pie chart and what is the use of pie chart is pretty simple. So whenever you want to represent your whole graph in the form of a whole circle, but if you want to divide the whole parts into different subparts. So for example, I have my day. So in my day I have 24 hours, but in this 24 hours what I will be doing is I will be trying to like split my 24 hours into 100%, that is nothing but a circle. So I will be dividing my tasks so that I complete my entire 24 hours. So that is an example of a simple pie chart. So in pie chart what we do is pretty simple. So we convert our entire data, that is nothing but whatever data that we have, we convert it into a circle. So we represent what part of our data is like being most used will occupy a large part of the circle. So what part of the data which is occupying a lesser part will occupy a smaller part of the circle. So it is a similar representation of a graph, but in this case we are representing in the form of a circle. So circle is the kind that we use it in the case of our our pie charts. In case of bar graphs, it is nothing but square type bars. So only difference between your bar graph and square nothing but your bar plots as well as your pie charts is, in case of your pie charts you will be using a circle, in case of your bar plots you will be using a square. So bar plots also can be used to compare multiple objects, but square your pie charts also can be used to represent your multiple categories of data as well. So how to use this bar plot? It is pretty simple. First thing that I will do is I will try one column. So that column of data that I will use is called as slices. So first I will do something. I will try what is my activities that I will be doing every day. So the activities that I will be doing every day is sleeping, yeah, I need to sleep every day. So then eating, so that is one part of my activity. So then working, so what I will be doing is working. Okay, so then what I'll be doing is nothing but my sports, that is nothing but playing. So what we are trying to do is, in one list we are trying to tell out what is the activities that we are doing. So the activities that I am doing is nothing but sleeping, eating, working and playing. So these are the 4 activities which I have stored it in the form of a list. But another activities I have, that is nothing but I need to store the duration, right? So I will take in 24 hours of my duration. So what will happen in my 24 hours? 7 hours I'll use it for sleeping. So 2 hours I'll use it for eating. So then I will use my 13 hours for working and my rest of the 2 hours for playing. So this is how I divide my 24 hours. So you can see that it is not 24. You can divide it into any number that you want. That is not a consideration. But since I am taking some thing that is actually makes some sense, so I am taking my entire duration as 24. You can take it as 25 also. It is not a problem at all. So 13 plus 2 is 15. 15 plus 2 is 17. 17 plus 7 is nothing but 24. So the total duration is 24. So out of that, 7 hours sleeping, 2 hours is nothing but my eating, 13 hours working, and again 2 hours of playing. So this is how I divide my entire data into. But I can even choose my colors also. I can choose my colors, for example. Okay, I will choose my colors as, okay, I can choose my colors as red for sleeping, blue for eating, then I have green for working, then I have yellow for playing. So this is how I can choose my different colors, because it even makes sense to choose different colors for different parts of the pie chart. So this is the thing that I want to plot it in the form of pie charts. But what is the simple thing that I can do is pretty simple. So I can use the plot.py function, so that will plot me. So what I want to plot is nothing but I want to plot my duration. So that is the thing that I want to plot with my label. So I need to add a label. So what is the label for my durations? It is nothing but my activities. So this activities is a variable that is storing my label. So what are my labels? Sleeping, eating, working, and playing. So that are my labels. So then colors. So directly you can define all the colors here. Since I have defined a list here, so I can give the same list here. So then I have something called as shadow. So what is shadow? So if you want to have a shadow for your entire pie chart. So why pie chart needs a shadow? Since it is a 3D representation, so you need to understand what a shadow is. So this I will try to give. So then what I will try to do is I'll try to plot the graph. So I will use the title called as my activities. Okay, so then I will use this plot.show. One second. Activity. So I made a spelling mistake, so that was a problem. Yes, my graph has been plotted right now. So you can see that green is for working. So I'll minimize it so I'll get a better understanding. Green is for working. So working, I've spent my 13 hours for working. So how is this getting divided into like the percentage? So if we consider our entire circle as my nothing but my 100%, so I can see how it is actually happening. So I can consider my circle as 100%. So what I'll try to do is I'll divide my 100. Okay, I will divide my 24 into 100. So whenever I have my 24 representing 100%, so if I am dividing it by 100, so what is the thing that I am getting? So it is nothing but my 0.24. Or if you do the reverse way, that is 100 by 24. So when you want to divide 100 by 24 parts, so each part is 4.116%. So if I am using my 7 hours to sleep, so it is nothing but 4.116 into 7, so which is 29% of my entire data. So this is my 100%, so I have my 29% of data. So this is how you can try to draw the graph. So if you are using this 13 hours for working, so what I will do is I'll use 13 into 4.116. So how did I get this 4.116 and what is the actual meaning? See, basically it is more than 50%. So you can see that 50% of my entire circle is divided. So to understand this, it is very simple. So I have my data, that is nothing but 7 plus 2, 13 plus 2, it is nothing but 24 is my total count. So what I will try to do is my entire circle is divided into 100. So this is my 100%. So out of my 100% of my total the data, so I will try to divide this 100% by 24 parts. So each part will be 4.116. So if I have 7 parts that I am using it for sleeping, so 7 4s are 28. So similarly 2 parts for playing and eating, so 2 fours are 8% of my entire circle. So this is how I can actually draw the graphs. But what is the things that we need to understand is pretty simple. You have something called a shadow. So if I remove this shadow, what will happen? So it is only a 2D graph. So there was no 3D effect here. So if I include a shadow here, so see this 3D part that is appearing. So that is also very important. So what we can try to do is, see, one thing is what we'll try to do is we'll try to understand how we can also add the percentages of all my data. So to add the percentages, I have a function called as auto percentage. So we have auto PCT, but we need to mention how our percentage will be represented in. So if I want to have only one decimal place, I can use 1.1f. Then I can use this percentage symbol. So this is how it is represented. So if you want to represent it, so yeah. So if you want to represent it, you can use this percentage symbol. So then that is how I am representing my data. So this is telling me that I need one decimal place. So what is one decimal place? So if it is 4.116, that is like it is 28 or 29%, it will show one decimal places. So that is how you can see the data that you have. So you can see here 54.2, 88.3, 29.2. So this is all telling us what is the percentage of data that we have. So as I told you earlier, so since this is 24 hours, so when you divide 100 by 24, each part is 4.166 part. So if I want to represent my 2 parts, which is nothing but my eating, so eating is 2 parts. So what is 2 into 4.16? It is 8.3 and 8.3. Similarly, 7 into 4.16 is 29.2. 13 into 4.16 is 54.2. That is how my entire data is getting divided into 100 parts, which is my full circle. So if my 100 part is full circle, so that is how my data is getting divided into different parts. Okay, so this 1.1f is telling me how I represent my data. So if I would remove this 1.1f or just use f or 1f for example, so what will happen, we'll see. So we'll just try to run the code. If you are using just 1f or f, what is happening is it is going to the maximum extent. 1, 2, 3, 4, 5, 6. 6 decimal places it is showing my value. But this 6 decimal places is not at all necessary. So what I will try to do is, I will use my 2 decimal places. So if I use 2 decimal places, it is 1.2f. So 1.2f is nothing but it is a floating point variable which is going up to 2 decimal places. So it is 29.17, 8.33, 54.17. So that is how you can vary the data that you have in your actual data part. So you can see how your data is actually getting varied. Yeah, so coming back, it is very simple. So we understood what is shadow. It gives you a 3D effect. So what is auto PCT? It is telling you how you represent your numbers. So if you want to represent it in terms of your decimal parts, or if you want to try to use how many decimals, it should come out. But one more thing we'll try to do is we have an option called as explode. So what is this explode is, if you want your graph to move out, that is, see, if you don't use explode, it is all the circles or all the parts of your entire pie. So this is pie are joined to this whole circle. So if I want this part to come out of my graph, so I don't want this to stay in my graph, I want this to come out of my entire circle, I can use this explode option. So what is explode option doing? So it is telling us how much to come out of this entire circle. So that is given in the form of a tuple. So I can tell that only the working part. So only the working part needs to come out of my entire circle. So what is this come out of my entire circle? So you can see here. So what is come out of my entire circle is this. So if you use this option called as 4, so then it is moving too far. So I shouldn't use 4. I can use option of 1. So if I use 1 for my third tuple, so you can see that this part is coming out. So what is this part? Why I have used 1 at the third part? 0, 0, 0, 1. So 0 is nothing but, first part is nothing but my eating, sleeping, then I have my working. So I have used 1 for my working, so it has moved out. So if I want to move all the data by few parts, so I will use 0.2. Again 0.2 here, then here I can use 0.4 or 0.5, which will move out very far. So this is 0.1. So what will happen is each and every data will move out. So this was my center of my circle. So each and every data is moving out of the circle. So that is nothing but your explode. I've used 0.5 here, so it has moved out the most, but some data I've used 0.3, 0.4, it is still closer. If you use 0 here, sorry, if you don't use anything, 0 is nothing but absolute circle, so it is not moving out of my entire circle. So this was the example of my pie chart. So in pie chart, you need to have two things. One is the labels for your pies or individual categories that you have. Then you have the total data list of, or the total data which you want to divide into 100%. Why 100%? We will consider the area of our circle to be 100%. So then if you want to divide our data by the 100% of my circle data, it is simple. So you have this, my total as 24. So if I want to change this also, it is very simple. So I can increase this to 21. So my 21, the total becomes 23, 20. Okay, the total becomes 25 plus 7, it is nothing but 32. So out of 32, it is nothing but my entire circle should be divided into 32 parts. So what should I do? It is nothing but 100 divided by 32. So it is 3.125. So each part will be divided into 3.125. So you can see how the graph will be actually displaying to you. So even though it is divided into 3.125, you can see that my data, so it was 3.125, two parts are playing, so it is 6.25. That is how you can actually vary the amount of time. So it is not a compulsion, so it is very like it is of user's choice of how to actually increase or decrease the data. So that is user's choice. Then colors, so which colors your graph wants to be, pies wants to be represented. All these are in order. So sleeping is represented by 7 hours, which is in red color. So and explode is 0.2 for sleeping. So that is how we all are in terms of order. So very important, you need to maintain the same order in order to have an exact output. So you are mapping your duration with labels. So label is nothing but the names. Color, that is nothing but the color of your graph. Shadow is making you a 3D effect. Autopacity is telling you what is the representation, how many decimal places you need. So if you want 1 decimal place, 1.1. So if you want 2 decimal place, it is 1.2. If you want all the decimal places, 1F you can use, so it will give you 6 decimal places. So then you have explode. Explode is telling you how outward your pie should move out of the circle. So this is how actually you are plotting a pie chart graph. So with this, we have our last part that is left, that is nothing but we have our last part, so that is called as your multigraph. So what is this multigraphs and why we need to draw this multigraphs is pretty simple. So this multigraph is telling us if I want 2 or 3 graphs in a single window. If I have a single window of a graph, I want to display 2 or 3 graphs inside the single window, what I should do. So then we have a concept called as subplot. So what is this subplot? So subplot is telling you that how actually your data is getting subplotted. So subplotted is nothing but inside a single window, how you are dividing your plots into different types of data. So this is how you can try to draw many graphs inside a single function. So what we'll do is pretty simple. So I have my x1, that is nothing but 1, 2, 3, 4 and 5. Okay, so then I have my x2. Okay, the nothing but 2, 4, 6, 8, 10. Just some random data. So to draw 2 graphs within the same window. See, earlier case, in case of our bar or just our plots, plotting 2 lines within the same graph is different. But we'll have 2 separate graphs that will be plotted separately inside a single window. That is what we'll be doing in the case of subplots. So we have our x2, x1 and x2. We have our y1, that is nothing but 10, 20, 30, 40 and 50. So then we have our y2, that is nothing but multiples of 5, 10, 15, 20 and 25. So just random data which you are trying to plot. But one thing what we are trying to do is, I want to plot x1 versus y1 as one graph, x2 versus y2 as another graph. But I want to plot it within the same window. I don't want it to appear 2 or 3 times separately. I want them under a single window. That is how we have a concept as a subplot. So what we'll do is, we'll use a concept called subplot. Plot dot subplot. So what we are trying to do is, we are trying to divide our whole window into 4 parts. So what is 4 parts? We are trying to divide our whole window as into 2 rows and 2 columns. So in 2 rows and 2 columns, what I will do is, the first graph that I will do is nothing but plot dot plot x1 comma y1. Okay, so now what I will do is, I will draw another subplot. So this is another subplot. So I will be using the same thing, that is nothing but 2 rows and 2 columns. Inside that, the second part will be my data. So plot x2 comma y2. So this is how I can plot the whole graphs between 2 rows and columns. So then to show the graph, it is plot.show. So to run this, so it is giving me 2 graphs. So what is the 2 graphs that it is giving me? It is pretty simple. So how to understand this graph is pretty simple. So guys, one thing about subplot is whenever you want to divide your data into different parts. So whenever you have your data or whenever you want to draw 2 different graphs within the same window. I don't want these 2 graphs within my single window. I have 2 different graphs to be drawn under the same window. So I will do subplots. So advantage of subplots, multiple graphs can be plotted within the same window. So if you're showing a person the sales report of first 5 years and next 5 years, it is very simple to show in case of your subplots because different graphs are there in the same window. So if it is a separate thing, it would look clumsy and it would be not appealing as well. So we have a concept called as subplot. So what we are trying to do here is pretty simple. So our entire plot, we are dividing it to 2 cross 2. So what is 2 cross 2? 2 rows. So we have 2 rows and 2 columns. So when we have our data into 2 rows and 2 columns, so out of these 2 rows and 2 columns, I am printing my I am printing my x1 versus y1 in my first data. That is nothing but first row and first column. So this we can divide it into 4 parts. So we have 2 to 1, 2 to 2, 2 to 3 and 2 to 4. What is 2 to 1? This position. I have divided my data into 2 cross 2, 2 rows and 2 columns. Out of that, my first area will be taken by this graph. My second area will be taken by this graph. So again, if I want to plot x1 versus y1 on my third area and fourth area, I can use this 2 to 3 and 2 to 4. But what I will do a change here is, instead of plotting my x2 versus y2 at this position, I will plot it at 2 to 4. So what is 2 to 4? 2 rows and 2 columns at 4th position. So what is 4th position? So I have, whenever you divide your data into 2 rows and 2 columns, obviously there are 4 possible places where you can put your graph. So if I want to change this, I can use this 2 to 4. So if I use 2 to 4, what will happen? So this is the data that I get. So what is 2 to? It is very simple to understand. 2 rows and 2 columns. So if you have 2 rows and 2 columns, it is nothing but 2 into 2. 4 kinds of, or 4 graphs can be plotted here. But since I am plotting only 2 graphs, I can mention the position. 2 to 1 is this position, 2 to 2 is this position, 2 to 3 and 2 to 4. That is how I can plot this entire graph. So this is how you can plot using your subplot. So what is subplot? Inside the same window, you can divide your window into different parts where you can plot your multiple plots within the same window. So how to plot it? You can use this number of row, number of column, and which is the position that you want to plot. So I can make this as a 3-3 graph also. So 3-3 is nothing but 3 rows and 3 columns. So this is also a 3-3 graph. So 3 rows and 3 columns. So if I want to try to plot this one, so 3 rows and 3 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how you can divide the data. So if I want to put it at 3 rows, 3 columns, at the last part, so I will use 3, 3, 8 and 3, 3, 9. So what is the total number of graphs that can be drawn here? 9 graphs. So I will place it at the last 2 positions. So this is how I can place it at the last 2 positions. So this is very simple to plot. Whenever you are plotting subplots, you need to see how many plots you are plotting. So 2 cross 2 is nothing but you can plot 4 graphs. So 3 cross 3, it is nothing but 9 plots. You can plot it simultaneously. So that is how you are able to plot your multiple graphs. So this was the tutorial on your Matplotib. So you understood how to get a data from your dataset using pandas, but especially using Matplotib, you understand how to actually plot the data very effectively and show the customer or the client how your data is being visualized. So data visualization plays a very important role, and that has been fulfilled by our Matplotib. So thank you guys, and I hope you had a wonderful session. So thank you.